Everyone's looking at me going, I don't get it. Yeah, but if I teach for too many more years, people won't know it. All right, so my friends.
Teach for like 2 more years, and like those kids will not know.
All right, here we go. So this was not the homework. This is what we're working on today. Again, that homework from 2-8 we'll be doing on Friday. So what kind of things are you looking at on this that you're not quite sure about? What can I help you on? Of course, because tomorrow we're doing a quiz. If you need help with the calculator, I can help you. But what on these, take an honest look at these pages. Tell me if there's something I can do. Yeah.
So on the back, where it talks about like interpreting a slope and interpreting the y-intercept, you just have to say what it is like.
Yeah, okay, so that's a good one. So is that like 10 and 11?
Yeah.
Okay. So for 10 and 11, they're basing it off of, I believe, this information. Six, 4, 8, 6, X. All right. This is, what is this? This is a study by Intermap Research. Collected data to look for the relationship between cholesterol level and systolic blood pressure. Hey there. So your X value is cholesterol, and then your Y value is blood pressure, if I see that right. The resulting was a low order positive relationship existed. Okay, so cool. And then we have an R value of plus 0.186. So that's pretty cruddy data, but they still have it. So if we wanted to interpret the slope, this is our slope here. So remember, our slope, 6486, it's the change in y over the change in x. I mean, that's the basic thing. I mean, y2 minus y1. So the y value, so your blood pressure increases as your cholesterol goes up by 1. Okay, so blood pressure increases by 0.06486 if your cholesterol goes up by 1. That's basically the slope. The y-intercept, though, it's not, so the y-intercept is basically this, 0, 71.33333. So, can I have a 0 cholesterol? Yeah.
I just have a question. What is this case number? Is it like 2153?
It's 24 to 26. So on the 153 to 155 is the review for it, so that can help. So this is more than likely an extrapolation of our data. I doubt we could have cholesterol of 0, but if we did have cholesterol of 0, our heart rate would be, or our blood pressure would be 71.33333. But it's kind of a silly thing because we all have some sort of cholesterol.
Okay, so then for number 12, you
12.
have to plug in -20 as that.
So if your cholesterol level goes down by 20 points, predict your amount of systolic pressure. Yeah, so you would plug 20 in for this X.
So would it be positive or negative? It's going down?
Goes down by 20. No, I think you would just,
it's,
Did we have an original? It doesn't look like we had an original. So I think we just plugged 20 in, and that's going to give us overall.
so it doesn't matter if it's negative or not?
It just said goes down by 20. I think it's just a numerical value we're plugging in. We didn't get an original.
Okay.
Like it didn't say, this year I was at this, and then if I went down by 20, I don't have something to subtract 20 by. So I just think we just plug 20 in, and it's going to give us overall. Yeah.
Will we be allowed to use a note card on?
Heck yeah! And if you need some, I got some up here. Hang on, I got a few people I have to unmark from being absent. And look at that, row 4 now became a good row. Somebody else? All right. Yeah, does anyone need a note card, by the way? If you do, come see me. And I'll, got a stash. Anybody? Gonna be shy? Well, it's on this first shelf here if you ever need one. And I will get out of your way so I'm gonna have the awkward reach in front of me type of thing. All right, what else do you see on the 155 or 153 to 155 that I can help you out with? Yeah.
Like this one.
Eve.
We're from the correlation of what?
Number 1, correlation. Okay. So, how that's going to be found? Let's see, open up my calculator.
Yeah, I just kind of made this bigger.
All right, so we're going to go stat, edit. I'm going to clear out all of my goods. Oops, clear down. Clear down. What's so smart? What happened? You what? Oh.
Would have been helpful if I had any freshmen here.
Gotcha.
Oh, yeah, that's right.
Yeah.
These days suck. They need to get rid of them. Oh, they really suck. Because I know you teachers don't like it either.
Let me know if you find a teacher that is excited about it.
My advisory teacher.
Who's that?
Insane.
Who's that?
Mr. Thompson. Yeah.
What does he do during advisory? That's so amazing.
He just gets so excited about it. He loves advisory.
Does he really? I gotta talk to him.
That means there is positive correlation between low blood pressure and cholesterol. If you draw them out, there would be a positive line of best fit and a correlation would be right here. You can go.
All right. So first thing you're plugging in your thing on the calculator, and I'll help you with this if you need it. If it's not turned on, you turn your diagnostics on, which is second catalog D, and then find diagnostics on. Mine should be on. Mine should be on, regardless. Quit. All right. So then I'm going to go into y equals. I'm going to clear this out. I'm going to go to, have to go back to my stat plot. Good, because I need list 1, list 2. This is all stuff I had done yesterday, so it kind of saved it. All right, and then zoom 9. So that's basically the data versus gross domestic product in trillions and an inflation rate. Okay, and so it goes through different countries. So if I want to find the correlation, just by looking at it, it looks like it has a pretty cruddy correlation. I'd say it's a negative correlation because if I were to try and draw a straight line best I could through this, it's going to be in this kind of fashion. Okay, but this is a really poor excuse for a linear correlation. So what I'm going to do is I'm going to go to stat, calculate, and I want the linear regression number 8. So list 1, list 2. Come on, baby, go down, go down, go down. Enter. All right, so this has an R value. We said it was negative, so that means we have a negative slope. This is like getting a 24% on a test. Like, no one's happy about that, but yet people are using this as statistics. So it has a negative correlation because my slope itself, my slope in this case is B. Notice where the B and the X. So it's a negative slope, but it's a really poor idea. If you wanted.
So would you just say negative? Or?
So find the correlation. I would say it's negative correlation. It's negative 0.24, something like that. Interpolate the correlation in the context of this question. It's a negative correlation. It's close to 0, so it's very poor representation, something like that. Find the equation of the regression line. That's the equation right there. Just realize that the B value up there is actually our slope M, right? So you just put that. Predict the inflation rate of your country with a GDP of 5.5 trillion. Okay, so once you have that, I'm going to go in there, go vars, statistics, equation. And again, this is what I can help you with on a calculator. And then graph it. So that's my regression equation. And if we want to check an inflation rate, I can go second, calculate. I want a X value of 5.5. So that would say that if you've had a GDP of $5.5 trillion for your country, your Y value is, your inflation is at 2.73%, something like that. And then do we trust the predictions made by this regression model? Well, some people might say 24% is really good on a test. I think it's pretty cruddy, but you defend yourself on that. Interpret the slope with the regression line. Sound like a water bottle. Fortunately, it's not a body going down those stairs. Boom! Oh, my head. All right, so the slope in the context of this problem. Oh, come on down. I got to see what the slope is first. So your inflation rate drops 0.065 for every $1 trillion more that your country makes. So, I mean, that's just such a small thing. Yeah. Yeah, that's the B value. Yeah, that's exactly it. And then find and interpret the y-intercept, and there's a regression line. So my y-intercept would be, this will be easier if I just go here, 8. All right, so my B value, or my y-intercept is actually the A value because we're going backwards, so 3.08. So if our gross domestic product is 0, then our inflation rate is 3.086 or something like that, and that's as a percent. So you'd have a 3% inflation if you have 0 gross domestic product. kind of goofy.
Um,
So I guess you could say, yeah, that's the more your gross domestic product, the better your inflation rate would be, vice versa. Anything else on there that you see? That was all first page. Second page we pretty much knocked out. Third page
the response variable is X, or is Y, right?
is Y. Yeah. Yeah. Explanatory is X, response is Y. So that's good to put on a note card. How many data points produce response variable observation that are higher than the regression equation would predict? So you're just counting up the dots above the line. Look at the data points with the highest value in the response variable. Draw a segment that represents the residual. So all you're doing on that is go here. So if we asked you something like that on the test, if you had your line of best fit like this, and this was your highest thing, you're just drawing in that. That's all you need to do. Estimate the residual for a point. So this point here would be an x comma y value. So let's say, I don't know what our equation is. Did it give us an equation? Doesn't look like it. So let's say they gave you some equation of this. Let's say they gave you this equation. This is this. If this point were to be the point 5 comma 7, and I'm making this up off the cuff, so it's not going to work. How do I find my response or my actual? Is you take that 5 and you plug it into the equation. And if someone has a calculator, I appreciate you doing this math for me real quick. 0.23 times 0.275 times 5. Anybody? Anybody? Plus 0.275 times 5. $1.605. So that basically means that we're going to compare, we're going to take this, we're going to go 7 minus 1.605, whatever that comes out. This would have been above, this would have a positive residual value, things like that. Is it possible for a scatter plot to exist in which every residual value is 0? And the answer is yes. If all of your data points fall exactly on your line of best fit, you're going to have a 0 residual value. What might the scatter point look like? It would be every data point would exist on our line. What would our correlation be? It would be 1 if it was a positive slope. It would be -1 if it was a negative slope. And is it possible for every residual to be positive? I would say yes. So, and where I would say that for 22 is let's say we had a bunch of data on a point and we had one residual off here. So that's totally possible to be positive. I mean, so the rest period's yours. Ask me any questions. We do have that quiz tomorrow. I think it should be a relatively well-rounded quiz.